Soul Electronics fan, and well, I've changed my mind. I changed my mind because I thought about it a minute, and I thought, well, I'm making an assumption that this is going to be a quick and easy fix. It may not be. And so I thought perhaps revisiting the Seeburg to see if I can get rid of that static might be useful for someone else who perhaps encounters the same problem. Now, one of the things I did that leads me to believe that maybe I damaged the tube, and I thought about this when I was doing it, and I went ahead and did it anyway. There's a rivet right here, which you can't see, but this terminal strip had a rivet right here, and I used a screwdriver and a hammer to tap on that rivet to get it free. And I'm concerned that maybe this tube being right there, where I was pounding away on it, might have caused problems with the tube. Unless you have very expensive tube testers, and even then, you may not be able to get a tube to make noise while you're testing it. So I have another radio here that has an SK6SK7. I believe that's what that is. Yes. This one, last time I ran the radio, worked. So I'm going to put this tube in this radio, and then we're going to check it and see what we have got. Oh, and I got to hook up my speaker. So I can't hear anything without that, and I've got to put it here. Got to get a label on that, because if I screw up and park things in the wrong place, I'll get wrong results, and that would be bad. Okay. I was playing with something else, and I got things rearranged, and well, I misplaced stuff. Alright, so that's there. Okay. So I have a new tube in there. So this is a quick, well, I would if I plugged it in, put it in. Let's put the tube in. Let's check you out here. So it's nice if you have a known good tube. And I got to fix that light bulb that tells me whether this thing is on or not, because I don't know if it's on. I think that's on. Do I have a filament? Oh, you know what? It works a whole lot better if you plug it in. Is that going to do anything? Come on. So that is working. There it is. Now I can hear the static already. Okay. The other problem I was having was that tube was ringing. And let's find out. Are we still ringing? Nope. So it looks like that tube may be microphonic. I'm poking away at these because I've had resistors break, but you don't know they're broken. Let's see. These are the tone controls. Oh. Oh, I have a noisy tube socket. Well, let's attend to that first. Try to get as many variables out of the way as possible. I didn't realize that socket was that bad, but I will. Let's see. How long are you? No, that's bad. This is a Raytheon, and the pins don't look that bad. They're discolored, but they don't look corroded. So, Oh, there it is. So let's try this. Okay. I'm going to try just hitting it with cleaner first. Of course, you can't see anything with me in the way. Let me just flip this down. So I am working on that off. I flipped the switch off on the amplifier, but I still had this or that switch over there on, and I didn't think much of that idea. Let's see. Oh, there it goes. I think that tube socket may have been I don't know, if it has been damaged or what. Alright, so let's turn that on, turn that on. Oh, you know what? I unplugged that speaker. It's going to be really hard to hear what it's doing without that. Well, that's not an issue. Well, let's try that one. This one's no longer making noise, and I should probably put this on here because this particular tube, I noticed when I touched it, is sensitive to, oh, yeah, that's a bit cruddy. So, like that. The first thing I want to do is blast some of the dust out of that socket. Yes, I know. Okay. Next thing we're going to do is clean this up. It's not terrible, but it is dirty. Well, let's see. This 600. This is 600 grit paper, sandpaper, and let me tilt this down a little bit. It's going to be working down here more, I think. So basically, all I want to do is scuff this lightly a little bit. That looks clean. And depends on, I mean, I've had some tube pins that have been horrendous. And a little polishing and they usually come back. Although I have had occasions where it took me a lot of work between the socket and the tube to get it to work. In fact, I think in that was my FM tuner, I think, where I had all that trouble, where I was very, very close to just replacing the socket because it just was not cooperating. And then finally it started behaving normally. And that was definitely a pain. And I was not happy with that one for a while. It was so bad that there was no output. It was the final tube in the output, yeah. It was the tube that was the final tube in the chain before the signal was sent onto an amplifier. And it was not playing nice with others. I don't know how much time I spent on that one, but it was really troublesome. This is looking a little worse than I thought at my first glance, but I think a little sandpapering will bring it back. And I am going to put contact cleaner in the socket, because I'm sure with pins looking the way these do, that's probably a good idea. Since I'm sure, and it's I don't know how often one is bad versus the other, but I think that the socket is much more likely to be your culprit than the tube. But sometimes they both are, so you never know. Okay. Where did I put that? I just had it. Hello. Oh, there it is. Okay, give you a shot. All right. Mess. And we'll go that way. Okay. Turn that on. See, I'm being confident and putting my sandpaper away. Nope. Oop, going too far out. Well. So one thing I've learned is that this tube, the one that was in here, is indeed microphonic, because the replacement tube is working much better. Well, so the question is it a bad resistor or something else? Now, my experience so far has led me to noisy tubes and noisy resistors. So those two I know can cause this problem. But the question right now is which? And when I was poking around underneath, I couldn't get any of those resistors to respond to me pressing on them or moving them. Let me go back under there and get in there more thoroughly, I guess. I'm going to do this without getting bent. Down. All right. course, the other possibility is that I have a bad solder joint somewhere. I'm extremely sensitive to that. And there are times when I will grab my very bright flashlight and double check my soldering job, because anyone who's watched my Pilot FM tuner video will know that I got myself in trouble when I was soldering. And the situation was, well, let's see, take for example, oh, I'm aiming down here again. I should always look over there. You've got 4 items on this pin right here. Now, if I were to only heat the outer end of this, take, say, that resistor off, replace it perhaps, and put it back, and I only heated just the end of the pin of the terminal, I run the risk of simply softening the solder back here, and it will crack, and it will give you a headache trying to find out where the problem is. That happened to my tuner. And so I suppose that's a vote in favor of doing J-hooking, and I've done both. I've got the new component wrapped around the terminal, and this one happens to be just J-hooked together. A lot of people like J-hooks for a variety of reasons, and there's a lot of them in this because there were so many components, and many times there were multiple connections to a terminal, and it would just take a lot of time to clean off each terminal before I replace each component. And so I just opted to, in many cases, and sometimes they're just hard to get to, the connections that you need to make. You can leave the piece of wire coming from the original component sticking out. You can J-hook to that easier than trying to get to a terminal connection. And try to get it, get it cleaned off and get the piece of wire. And the other thing that I've been doing, which has been helpful to me when I decide that I want to remove a component, or remove the wire from the terminal and solder it directly to the terminal, is I cut the lead off from the component, and then I use the lead and the soldering iron to try to unwind it from the terminal, because these are wound around these, and that has worked pretty well. Yeah, that tube is a lot better, so I'm going to have to replace that. That one I took out, it's no longer ringing. I just touch it. Well, I think I've tapped and pushed and prodded on everything in this thing, and I can't find my noisemaker. And on something like this, I have a nasty feeling that the static is capable of traveling in both directions. So if I try to use my audio signal tracer, I'm not sure if I could pin down where the noise is coming from. Well, of course, what's really not helpful is when it decides to stop making noise. Let's see, I've worked over here. I really don't expect the problem to be over here. It's more likely to be in this section where all the audio stuff happens. But everything looks like I've soldered it properly. I don't see, and sometimes you can actually see the crack in the resistor, but other times they hide and you just don't. Wow, this is really bizarre. Oh, I may have found something. Oh, there's something going on here. It's either the socket or that resistor. Yeah. I think that's my problem child, right there. And I don't remember if I cleaned that socket or not. Did I? No, I did not. I did wiggle the tube from above, but that resistor looks a bit dark. It doesn't necessarily mean much, but this is the resistor right here. Oh, come back you. And right there. And the lighting is not doing it any favors, is it? No. But yeah, that resistor looks dark, and it could have a problem. But before I condemn that resistor, I'm going to pull this tube out and clean it. And of course the tube is nice and hot now. Get a rag. So, let me back this out. Oh. And this is down there. Let's see, what does our tube look like? Pins look good. Okay, 6SN7. I don't know if I have one of those. Let's flip this over so I can get a straight shot into that socket. Well, that's something I didn't expect. Well, here's where my assumption is proven false. I thought I was going to find that either a resistor got overheated when I was replacing components on the same lead as the resistor, or that the resistor simply broke. And okay, let's go flip it back over and see what we got. Got stuff all over the place here. So I believe, what did I do with my stabber? What did I do with it? There you are. So I believe that's my problem child. And I have one of those? 47K, I believe. 47K. I should have one of those. And it looks like a half watt to me. 47 ohms. There's a 40K, but that's a quarter watt. 47K. I do have one. Or no, 4.7. No, that wouldn't work. 47K. I got one. And I think it's probably 1 watt. I think I bought a bunch of those at one point. Okay, well, let's replace a resistor and see if that makes any difference at all. Let's see. Okay. Having that nice big screen there makes it very nice because I can probably see things better using that than I can looking at it directly. I don't see any cracks in it. But here in the middle, you may not be able to see it. It's a lighter brown color out here, but here in the middle it looks very dark. So it looks like this resistor has been overheated at some point. And so the tube is in there still. All the tubes are in, ones I can see. Alright. I don't know if that's going to fix anything, but we're... Flaky resistors can give you a headache, that's for sure. Well, it's up, I can hear it. I'm not hearing any static. So it looks like I solved two problems. A microphonic tube and a noisy resistor. A noisy resistor was my first culprit, my first thought when I started getting that static. I was a little bit, I am a little bit surprised. Let me think. I'm trying to remember if I tested this amp after I did this section or if I did everything and then tested it. And I can't remember. But one of my rules is if you have a problem, go back to the last thing or the last section you were working on or the last component you replaced and make sure you didn't screw something up. It's a rule that has served me well, and so that's why I was looking in this area, and that's of course how I found my microphonic tube, because I was tapping around and boy did I find that. So that's dead, unfortunately. I'll have a friend with tubes, he'll sell me one. Well, I think, yes, before I could tap on that other resistor and you could hear it in the audio, and I'm not hearing it now. I do believe that was my problem. Well, now, I kind of wished, there's this switch right here, I kind of wish that I had shown you how I fixed that, because my original idea for repairing that didn't work out exactly as I intended it to. But let me see if I can explain. In fact, I think, well, let's shut you off. I'll come back to this in a minute. All right. No. All right. We are going to try to zoom in again. And here we are. can't. Let me try to bring this up. Okay. I think you'll notice that there's a rivet on each of these. All of them were riveted. What happened to this one, and you can see my solder poking up through here. You don't see the rivet anymore. What I did, well, what I was hoping to do was I took this little piece off. I take all the wires, unsolder all the wires, take this off. And what I was hoping to do was pinch together what was left of the rivet, push it back through the hole, and bend the ends back over. Unfortunately, who knows, well, it's brass, it's old. A good portion of the rivet, the top part of it had broken off. There was just nothing there to bend over. So what I started out doing is I clamped this in place, and I started feeding solder into the back side of this, hoping I could get it to mushroom out, and it really didn't want to do that very well. And the other problem I had was that the rivet, this rivet wanted to come up and out, and then when it did that, this didn't. Okay, I got interrupted by a phone. So what was happening here was this rivet was working its way out, and so that this wasn't staying put. The little there's a little angled piece of metal here that comes over and up to the terminal here, and so this part that goes down inside the switch was lifting out, which meant that the end of this wasn't sticking in far enough for the switch to actually make contact with it. So I then worked on getting solder onto the outside face of this to get this rivet to stay put. And I finally got it. I had to clean it and hit it with my rosin that I have, my paste rosin. And I finally got the solder to stick to the terminal. So then once I got that back in, once I got the rivet secured to the terminal, I forced this back into place, and then I took a pair of pliers and I put a lot of pressure on both sides of this, on this side and on the back side. And in doing so, I actually squashed the solder, mushroomed the solder enough so that it then held this terminal in place. And so I was able to save the switch. I hope I wasn't too muddy about that. So, but the bottom line is, I fed solder all the way through from the outside to the inside. When I got a ball of solder on the inside, I then squished that so that it would hold things in place. Now, solder is not all that sturdy. It's decent, but it's not all that rugged. So I decided that, number one, this switch is not going to get used a lot, and number two, there's not a lot of stress here. It's not like that something's going to be pulling on it or yanking on it. Boy, I moved my finger around in this. Boy, that's kind of distracting. Anyway, so it's not like there's going to be a lot of stress on this point right here. And it's a slide switch with all of these connectors are flat, and there's a little piece of metal that's shaped like this that fits on either side of the flat pieces. And so when you move it up and down, or the switch along, the fingers formed by that little U-shaped piece grab either side of this contact. So there's not a lot of stress there. I really have no clue how that broke. And I didn't even do it. The solder on this was the original solder. I had not even touched this. And I don't even know, because I did the J-hook here, I don't even know that I put stress on that. So it's a puzzle to me how that broke. But I got it repaired. It's working just fine. I've tested it. It's doing good. Okay, I am experiencing some odd stuff, and that tube I stole out of another radio may have gone bye-bye. Oh, gotta have a speaker so I can tell what's going on. And I keep forgetting. Oh boy. Alright, so this is the speaker. Alright, try that again. Really don't like having that run without one. It's not a good thing to do. So, I put that tube in. It seemed like it was doing fine, and it started acting funny. Microphonic and stuff. I turned this off, I turned it back on to test something, and it produced this horrendous racket and blew the fuse on my speaker, which fortunately I had put one on it to protect it. And that was kind of a surprise. Alright, so 6SK7 is right here. Alright. And pin 4 is here. And I have replaced this capacitor. That's brandy new. So where would I be getting voltage from? That shouldn't be there. So I just checked that capacitor. The value is correct, and my other test gadget says that it's fine. But so when I measured, I measured off camera that, and this voltage starts out at 24 and it starts dropping. And even though this is high ohm meter, oh, I've got an O2 that was not changed. Oh, okay. That's where I stopped. I thought I had changed that one, but I didn't have the 600 volt version of that, so I didn't. Okay. Well, this may be messing with me. I mean, this is the tube I'm concerned about, but I don't like that there's a bad or potentially bad capacitor in this circuit here. So that's what's going to happen next. Is I am going to replace all these capacitors once I get them. Then we'll come back and take a look at this and see if things have improved. And one can only hope. But this is definitely a challenge. And these guys are very handy, because you notice I wasn't making any noise when I was poking and prodding. That's why. When I had that capacitor unhooked, and I went and tapped that with the speaker hooked up, not good. It made very bad noises, very loud noises. And so rather than take out the speaker or do something else bad, I just hooked this up, which works. This is 100 watt, so since this is only a 25 watt amp, that was more than enough. So, oh, my ground popped off. That's not good. That's not good at all. Alright. Well, anyway. Got me baffled, but now that I spotted that O2 having not been changed, yeah. And that could be my problem. Let's look at this. Let's go back to this. Here's the O2 that I thought I had changed. Let me zoom in a little bit so it's easier to see. Whoops, wrong direction. Okay. Yep. Let's zoom in some more. Okay, so there's my O2. That's the one that I thought had been changed. It's got 285 volts coming from here. If this thing is leaking, it could be driving the voltage up here far more than it should be, which could lead to this being higher than it should be. So, I'm pretty sure that that's my culprit right there. And I thought I'd replaced all of the capacitors except the O5s. I forgot about this one. I had an O2, but it was a 400 volt, and I can see why this spot right here when this is starting up, it hits about 520 volts. So you really don't want to go smaller on that capacitor than they call for voltage, or lower voltage. That's not a good idea. You terminate that capacitor. So that may be my culprit, and all because I forgot about this. Alright, well, I guess I'll be back once I order the parts I need, and we'll see if that fixes the issue. But this is an example of why it's potentially a bad idea to leave old capacitors in here. This amp is more complex than stuff I'm used to working on. I'm used to having the coupling caps pretty much show up at the end of the audio chain in the first amp audio tube and the second audio tube. That's the point at which I start looking for coupling caps to change. This has a whole lot more going on than I'm used to, and I really should have, and I have been looking at this, trying to sort things out, because this is beyond my experience. Okay, well, there are a couple of things I want to mention before I do a final bit of testing. So I want to read voltages, a couple of voltages, before I change out this capacitor. It's always good to learn about stuff. So this tube is the 6SL7 and this is the 6SK7. So let's see if we can cruise in here a little bit, and I'll show you what I'm looking at and why. Alright, so we've got these two tubes. This 6L7 is dual triode, so they've split it in half. So that's all one tube. Most of you know that. So what we've got right here, we've got this 285 volts on the plate of this tube. We've got this O2 capacitor, which is this one right here, which comes over here and goes over to pin 3 of the 6SL7. So what I've done right now is I've got, what did I think, I didn't mark that, so I don't know, but I'm betting that's the 1 megohm I've got here, probably. Alright, well let's go from this part. So right now I should be on, yes, so right now I should be on pin 3 of the 6SL7, and because I'm on the other side of this, I should be getting full plate voltage at this point, which is on this meter. Oh, yeah, I'll come out. The meter on the right has the plate voltage side, and the meter on the left, which you'll see in a minute, is going to be pin 3 here. So what I want to do, and then I'll probably just do a quick check of the voltage. Well, yeah, let's see, do I want to, yeah. So if we go up here, zoom back out a little bit here. So we've got this resistor goes up to the, connects here, and then connects here, which is pin, what are you, 1, 2, 3, 4, on the 6SK7, yes. Alright, so this is the grid connection, and this is where I read such high voltage before. Now, a couple things I want to mention though. I said something, and in hindsight I think it was kind of silly. I mentioned how if there was no current flowing through this pair of resistors, then you would expect to see whatever voltage you have here. And while that's true, the only way that would happen is if this tube were dead and not conducting at all. As far as I can tell, this tube is not dead. It is working. I can't remember if I checked the plate voltage on this or not, but I have no doubts that this tube was actually functional, and there should probably be some kind of current flowing through here. So that was kind of nonsense. The other thing I want to mention is that the Yes. The fact that this is not distorting is also not the smartest comment I've ever made, because when you look at the circuit diagram, the primary circuit flow is through here, your tone control circuits, and then ultimately through, and the ABC part is part of this, but I don't know if I have the switch on or off right now, but this is your primary audio chain here and here. So it's kind of going around this part. So this part could be completely shut down, which it kind of is. If you turn this off, it doesn't do much. And and this could be misbehaving unless it was really, really bad and really injecting distortion back into this audio chain. You're not going to hear it, and you're not going to notice it. So the fact that this sounded pretty clean has nothing to do with whether this is working or not properly. I'm betting we're going to find out that this tube is probably getting roasted, and it may have, I think there's one tube that's already terminated because I put it in there, unfortunately. So anyway, so I want to take a quick look at what voltage we see here and here, and then I want to take again a quick check of the voltage here. Then I'm going to change this capacitor, and then we'll look at those same spots again, because that will tell me what's going on. It took me a while to figure out what was going on because I thought this had been changed. Sadly, I had not changed that because I didn't have the right value, unfortunately. So that may have resulted in terminating one tube, and I don't know if this tube is healthy or not. Right now it's ringing, it's acting microphonic. The other tube is in even worse condition because I think it is injecting nasty noises back into the signal chain. At least that's my guess. So anyway, so I'm going to turn this on, and we're going to watch these values, and we can zip this out a little bit, a lot of it. Alright, so, okay, there we go. There's some voltage climbing up. So over here, this is what's on the side of the capacitor away from the plate voltage that's flowing there from that tube. What tube is it? Yes, this tube, I think. What tube am I looking at here? Oh, this was the other half 6SL7, which is there, and it is that tube. Alright, so right now I've got 19 volts here. So I'm going to check this over here. And it's 17, 16 volts. So that's definitely not nice. So now what I'm going to do is I'm going to change out that capacitor. Then I'm going to come back and we'll check these same spots and see what we've got. And I'm pretty sure we're going to find out that the voltage on that tube, the 6SK7, drops back to what it's supposed to be once I change that. So, I shall return. Alright, so the capacitor has been replaced. That dinky little thing replaces this. I still look at how small modern caps are compared to the old ones. So fire this up. So we're watching our voltages climb over there, and we're seeing quite a difference over here. And that's grounded. Everything looks good. That's still connected. So I think it was 19 volts last time. So I've got 322 volts on this side, and I've got 1 on this side. Let's see what this looks like. And this, alright, let's go down. So I've got 0.76 volts, something like that, 0.75. That is a significant difference. The tube manual says this should be maximum of 0. I think 0.7 is very close to what that should be. It's far better than the 16 volts that we just measured, and definitely definitely a bad thing for that poor tube. I'm pretty sure that one tube I swapped in here is taking a dump. It was making horrendous noises all of a sudden when I fired this thing up with that tube in there. So I have no doubt I'll be replacing maybe not one, but maybe 2 tubes. Not great. But here's what I want to do before I go any further with this. There are those who say that these can be used if they're, oh, I don't know, around 20-30 megs resistance. Let's find out what this is. I'm kind of waiting for my meter to warm up. But, well, let's take a, oops. If I don't wait, then I wind up recalibrating. But I'm going to do it anyway. Come on, let's go. Stop it. There. And so we'll we'll zero this out, because we're going to be looking at, that looks pretty good. Alright. I think this will be closer. Alright, so let me show you before now what I've got here is I've got these two are connected to the same spot on my meter, and this is just a quick attempt to get this back to 0. It doesn't always work, but so what we're going to do, let's see, is we're going to move this up. Well, actually what I probably want to do is just move this in so you can see the meter better, and there we are. Okay, so here it is, and all I'm going to do is just tap this on here and see what happens. Oops, and that's what I was mentioning earlier. Sometimes they don't zero out completely. So if you get your meter heading in the wrong direction, that means there's still a small charge on here and the meter's reading it. And so let's try this. Okay. So it's 20 megs, 50 megs, not quite, somewhere around, well, if I line my head up properly with that meter, actually it's showing up pretty good in the camera too, it's about 50 megs. And it's pretty much stopped there. Okay, so this capacitor measures 50 megs, which is not what you should see for a decent capacitor. It's, as we saw, very leaky. It seemed like, trying to remember, almost seems like at one point when I was measuring this, I was seeing around 30 volts getting through this, but we did see that it was around 17 or so. That is enough to toast a tube. So my conclusion is that even though this measures 50 megohms of resistance, and that seems like that should be, 50 megohms is fairly high resistance. So you would think that this would be safe to use, but in this circuit we had 300 volts on one side of it. And that 300 volts, and because of the internal resistance that this has developed, 17 volts or so, 19 volts, somewhere in there was getting through this. And it was enough to take out that tube. I'm pretty sure that one tube, if I test it, it's probably toast. I will test it before I condemn it, but I have a feeling that that's what's going on, or that's what happened when it started making bad noises. So I'm not going to even run this until I get the rest of these replaced. I do have replacements now, and think all I've got left, what have I got? Got that one, and that one. Maybe there's only 3 left that I have to get changed. That could be. So I'm going to do that, and I think at that point I'm going to call this done. I'll flip it back up, and we'll see if it makes any difference in how it plays. I doubt it will, because as I mentioned before, this circuit is kind of outside of or alongside the main audio chain. Kind of goes like this, and this feeds into it. This stuff down here feeds into the audio chain somewhere around here. So its basic job is to, and I see some feedback going on, so its basic job is to reduce, I believe, is to reduce the input here if the signal level is higher than whatever level this was set to. So the idea, I guess, is you set the volume where you want it, and this circuit is trying to maintain a relatively stable volume level. And so if that signal level goes up too much or down too much, then this circuit will try to adjust to accommodate that change in signal strength and try to keep it on an even keel. So this can, as I found out from this tube, this can affect this chain, because it was making horrendous noises, and thankfully I had a fuse on that speaker, my test speaker. That's something to consider for future test speakers, I guess. So it saved my speaker from getting toasted, because it would have, if that had gone on much longer, I think that speaker would have gone bye-bye. But thankfully it didn't, because of that very nice fuse. Alright, so I'm going to finish this up, and when I come back, I'm going to hook up the test speaker here, and we'll see what we can see. And the only other thing I've got to do is I've got a pair of capacitors over here that are going to go away and be replaced with, oh, actually they haven't arrived yet. But I've got the correct value capacitor coming for this, so I can get rid of these double capacitors, and then I can call this done. Then I have to decide what to do with this. I have a vintage op amp style Fender amp that I'm playing with, and if I get that working, then basically I don't really need this. So I may see if some guys that have jukeboxes that can use something like this might be interested. I have no idea what it's worth, but I know I've invested in it quite a bit material-wise, and I've been really bad about keeping track of that. But I probably got somewhere in the neighborhood of $30 worth of components in here, I think. I should look. But, and the big part is the electrolytics. They cost more. So anyway, I'm going to finish these other guys up. As you can see, that's one of the CD model or brand or whatever they are. CD USA. Well, and I think these might be Sangamo, but I've got some Sangamos that were not very good either. Oh, I want to mention one other thing. One of the things I tried to do is I wanted to position all my components so that the values are facing upward. Some of these are that way, some are not. I tried very hard to make sure that all of my capacitors are facing, or have their size, the printed size, facing outward, so that number one, if I make a mistake, I can go back through and say, oh, you're not the right size. I don't have to cut it or twist it. So I don't like twisting them, because you can break the wire off, and I don't know what kind of stress it does to the connection inside. So I'd rather not do that. So I try to make sure these are all aimed upward. Of course, you can't twist these. You've got to cut one end or something to get them up so you can see them. So my goal is, whenever possible, you can't always with electrolytics, but whenever possible with these, possible meaning remembering to do it, I try to make these components face outward so that I can see what they are. And it makes it a whole lot easier and faster to troubleshoot. Alright, so I'll be back after I install these, and maybe I'll do a quick check of some voltages just to see what it looks like when I'm all done. Alright, well, I did some quick checking off camera, and this voltage is after I replaced those other capacitors, 0.9. Yeah, this one was still, plate voltage is a little bit higher than what that calls out. Let me see, 285, and this is 322, so I'm not sure why that's so much higher. And I know all the resistors that I've checked on this have been high, or either high or okay. None of them have been low. Alright, well, I decided I wasn't happy with the voltages I was getting. It's kind of concerning. And I know that there is a certain range of voltage, that the numbers that they give you in the schematics aren't going to be precise, but these seem to be more than I liked, especially the 12SK7 right here. This, where am I? Right there. Oh, I'm in the wrong one, right there, next to the tube. This is actually the grid right here. That's the right place. This went from being almost, well, 17, 18 volts, 16 volts, somewhere around there. I think it was 17, 18 over here. This was 16 volts, and now it's down to below 1 volt. I would rather see this closer to 0, since the tube manual says that 0 is probably the maximum you want. 0 or a negative voltage, and it's not a negative voltage. It looks like it's a plus voltage. Plus, the voltage here is supposed to be 285, and it's at least 325 or so. You're talking about a 40 volt difference, and if it weren't for this voltage being higher than I wanted it to be, I might say that's okay. So started pondering, well, where does the voltage for this section come from, and should I look at something having to do with this? And this is rather interesting. They show you this here, and they call it R48, which is one resistor. And thankfully, this resistor is the original resistor that came in this unit. Well, maybe not thankfully. If it had been replaced, then I probably wouldn't be looking at this. I was questioning whether this really was the right resistor, and then I looked on the side of the resistor, and it had a part number, and the part number matches this reference number in the parts list. So I know I have the right resistor, and what this is this thing right here. I think it's in the way. Oops, yes. So, can I swing you a little bit? Maybe, just a little? And we'll do this. Alright, so, this is a resistance between here and here, and between here and here. And I finally figured out, and I'm going to write it down so I don't forget. I was a little confused at first, but this part, which I will show you in a minute, is supposed to be 25K. And then 2.5K. Alright. So, I got sideways for a minute. So this is this R48, and it's supposed to be 25K between ground and here. It's supposed to be 2.5K between here and here. Well, this one looks okay. In fact, let me show you. So this, except you can't see anything. Oops. Hey, that can really go in close. All right, let's go there. All right, so I go from this point to this point. And, well, stop dancing, will you? And it's a little over 2.5K, but look at this thing. And I have no idea. Okay. This keeps changing value. It's been 6 megs, it's been 12 megs, now it's 8 megs. There's corrosion right here around this pin. I'm betting that inside of this is a little tower that sticks up into the above the chassis here, and it's about that long. And it's a 20-watt resistor. So I got to find something to replace that. And I'm probably going to I'm going to replace both 2.5K and the 25K, because what's happening here will happen here at some point, I'm sure. So why would this be a problem? Why would it give me, oops, I gotta remember which way is which. Alright. Well, I think what's going on here is basically what you've got is a voltage divider from what I can see, and the purpose of this voltage divider was to provide a particular voltage at this point so that the voltages downstream would be correct. So given that this is no longer 25K, but rather it ranges between 6 and 12 megs, this voltage divider is no longer providing the correct voltages downstream like it should. Like I said, it's like a 40, well, it probably depends on what mood that resistor is in, what I wind up with for a voltage down here, but I know it's at least 40 volts off. And like I said, depending on what it does, I mean, it started out at 6 megs, and it seems like it's progressively, well, somewhat getting worse. You can't really see the corrosion around the base of this pin, but there's green stuff growing around it, and that's not good. When I saw that, I was a little concerned, or a lot concerned, I should say. So I'm guessing that once I replace this with something with resistors of the correct value, that will bring the voltages back in line with what they should be. Like I said, if it hadn't been for at least one of the voltages being higher than I want to be, now that may not solve my problem, but the voltages in general are higher than I think they should be, better than I really want them, or higher than I want them to be. And the other thing was, I don't think, I should have made notes, but I think these voltages are closer to what they're supposed to be. And given that these are definitely not 40 volts out, and that this voltage down here is way off, that's what led me to look at this. And I'm pretty sure, so I was debating about, well, what should I do? Should I, and I'm so glad I just didn't go charging in and do what I originally thought I wanted to do, which was to put a larger resistor in here and bring this voltage down. But by doing that, now I'm affecting this area over here probably negatively because this feeds down into the output transformer. So I could make the voltage here lower than it should be, trying to get this voltage here where it's supposed to be, and that's obviously not recommended. So I'm glad I dug into it a little bit more, started measuring things, and I did find that this is definitely not healthy. Of course, it would be a 20-watt resistor. I'll have to hunt and see what I can find. I've got a fair amount invested in this between time and materials. There's a fair amount I've put into this. I don't begrudge that, and if I finally get this thing working the way it's supposed to, completely the way I want it to, then I'll be happy with that. Even if I wind up selling it, which I have no idea what it's worth, but basically, if I'm going to sell something, I want to make sure that it's working properly. So, regardless whether I keep it or it goes to another home, I want it to work right. I don't really want to keep running this, knowing that this is probably causing the voltages in this thing to be higher, quite a bit higher than it's supposed to be. And there's some wiggle room when it comes to tube stuff, but to me this is just too high, and I'm not happy with that at all. So I will see what I can come up with for a resistor. And it looks like there's a rivet. There's a rivet right there. I think that there's a bracket that holds this in place, and there's a rivet right there. So what's probably going to happen, because I'm going to want to put a terminal strip in there, I'm going to have to probably drill that rivet out, take this out completely. And part of me really wants to keep that in there. Can I see? Yeah, there's a... Yeah. Well, maybe I can find another way to mount that, or another place to mount what I want to mount. Well, anyway, I will figure it out. Alright, well, I found a resistor, not exactly what I was hoping for. It's what it's supposed to be, 20 watt, 25K. It's big. It's going to make it a little bit harder to put into place. The other thing I ran into when you're dealing with high watt resistors, trying to find what you want, in this case 25K and a 2.5K 20 watt resistor from the same source, not easy to do. So I found this. I'm going to install this, and because I want to get this thing relatively done. I'm thinking I still want to replace the 2.5K part of this, but because that part is measuring correctly, I'm not going to do it now, because my real goal here is to see if I can get the voltages in this thing somewhere where they should be. So I've got this mounted the best I can. I still don't know quite what I'm going to do. So I would like to replace the 25K part of this, but it's interesting. When I heated this up with my soldering iron, this is the 25K part right here. This went up to 60 megs, and then when it cooled down, it dropped back down to something closer to what it's supposed to be. So let's fire this thing up and see what we have got. Well, actually, let me just check something, because I need to know, because I've got this back on my variable transformer since I know that I'm not going to overload it, and it's only drawing about a little over an amp, so it's not stressing that too much. So let's see, let's go here and here. It's AC. I getting the right connection? That's AC. Oh, 113. Okay, so let's bring you up a little bit. Alright. 119, that's close enough. I think they say 117, but hey, we'll go with that. So let's go to our DC volts again. So let's go back here. And now it's 318, and it's supposed to be, I should remember that by now, 315, okay. So now I go over here to pin 5 of this, that should be 284.9, yes, so that voltage is dead on. Alright, so that's this point right here on pin 5 of the 6SL7. So the next thing I want to know is, what's the voltage right here on this one, which is pin 3, 1, 2, 3. That's 1 volt. That's 0.9, 0.8. We're dropping. Okay. And then we go here. And the voltage has gone up, not down. That's not right. All the other voltages are correct. Well, I'm cutting into this video because I've spent way more time on this than I really wanted to. I thought this was going to be straightforward, but it turns out it is not. So here's where I'm at. I checked this tube out. It is shorted. Junk. This tube, depending on which tube tester you use, well, first of all, neither one of them says this is shorted. One of them says it's junk, the other says it's fine. I did put this one back in here, and it did work. It didn't produce any bad noises. It worked. Here's where I'm up against, and here's why I'm bailing out on this. A couple of reasons. Number one, I don't need to replace this tube. I'm not going to use ABC on this. If I sell this, I'll let somebody know that they're going to have to replace a tube and then troubleshoot the ABC. Have somebody who knows that circuit better than I do. I've got the suspicion that that circuit is non-standard. I don't know. Because if you look at this, and it goes with you in here, let me just focus, please. Alright, here's the tube that's our primary ABC tube. And my problem child is right here at this point, basically. All the other voltages, once I replace that resistor, this resistor right here, all the other voltages came into line. Everything's working properly. I have tested everything in here. I have checked it thoroughly. All the components measured to be the right values all the way around this. I can find nothing that explains why this point is running at around 4 or 5 volts. And it starts out around 2 volts and then climbs its way up, which doesn't make any sense. It makes me wonder if this was designed specifically for however they're using this. This I believe is the ABC circuit. I believe this is preamp stuff. This is for, I think this is a preamp for the magnetic cartridge, and then you have another preamp, and then you have your basic pre-driver or phase inverter for the output. Because I don't care about ABC, this works just fine without it. It will work fine. What I'm going to do is I'm going to pull this tube, and to make sure this circuit is completely out of the loop, I'm taking this capacitor out, which is something that was suggested somewhere, which I can't find right now. And I think that will cut. This capacitor allows signal to come from here into here. If I take this capacitor out, then the signal will stop coming into this tube. And with no tube there, then nothing's going to happen. So that's what I'm going to do. I'm going to stop for a moment. I'm going to pull this out, and then I'm going to pull, and I've already pulled the tube out. And then we'll come back and do a final listen to this, and then I'm going to call it done. This has led me on a merry chase. I'm glad I found this, because all the other voltages in this section that I needed, that I was worried about, they're all dead on now. So that was a good thing. This is the only part that has frustrated me, and I don't know the circuit well enough to know whether this is good or bad. I did have this tube in there. I didn't see that the plate was getting hot. The tube wasn't getting excessively hot. So those voltages may be fine. I don't know that. But again, and I don't know if that tube is any good. I don't really want to invest in another tube for this. I've decided I don't need ABC. So I will be back after I take care of this part. Okay, I've removed this tube. It's gone. I removed the capacitor. And I am calling I'm calling this done. So I went out and found some, hopefully music that, I found some music in the YouTube library that I liked better than what I had. So check it out and see how it sounds. This unit has always sounded really good. Well, once I got the capacitors replaced, it sounded really good. So let's see what we got here. Well, I didn't expect the automatic volume control to do much when I flipped it, but it does change. It changes some resistances, and it rearranges things. So I guess the switch does do something a little bit. But as you can see, it works just fine without that tube, without the ANC in circuit, or the ANC circuit working. This is definitely far more involved than I expected it to be. I fully expect to be done with this and on to something else a whole lot sooner. It's been interesting. I've learned a few things. Oh. I don't know if this one does that. Well, let me back up. In the course of trying to learn more about the ABC circuit in this, I ran across something that I thought was rather interesting, and it probably, and I think, actually I'm fairly certain, explains why this 6-volt power supply was separate from the main power supply transformer. And the reason is pretty simple. Jukeboxes sit for a long time. Well, they can sit for a long time between uses. And you don't necessarily want them drawing full power while they're just sitting there idling, and you want to try to conserve the tubes as much as possible. So what they do, I'm assuming this one did also, this jukebox, the 6 volts is separate from the amp because they wouldn't be able to do what they do in this power saving, tube saving approach that they used. Because normally, and I don't know, this might be the output to transformer, this might be the power transformer, but normally your 6 volt, B plus, 5 volt, all of those are in one transformer. And to do what they wanted to do, that they couldn't have that. So they took the 6-volt part out and put it elsewhere in the jukebox. And again, I think it's probably used to power things like the lights on the jukebox and so on. Because what they're doing is the filament voltage stays on in these tubes, which keeps them warm and ready to go. But the main power transformer is shut off, which means that basically your amplifier is off. The only thing you're doing is heating filaments. So then when you put your quarter in there, or a dime, or whatever it was back then, the minute that tone arm starts to move, it turns on the main power transformer, which means that in seconds this thing is ready to play. So by the time the tone arm hits the record, this thing is working. So it's a kind of a clever idea. I didn't really understand what they were doing with this, why they had this separate, but now I think I know. It's a neat idea, and I'm assuming it probably did make the tubes last longer. Some people said that the tubes in the jukeboxes they worked on weren't bad very often, and probably this is why they were not idling at full power all the time. They were just their filaments were running to keep things ready to go. So very interesting. Something I did not know. Kind of interesting approach that they had there. So this rascal definitely ran me around in circles trying to figure out what was going on. This resistor, which you probably can't see. Let me just see if I can swing it a little bit. Maybe you can after that. So that resistor is this thing hiding right behind here. And I looked at that and I kind of ignored it. There's also another small one here. This one's a 300 ohm high watt resistor. I should have checked on that. I should have figured out what that was. I didn't. And it worked out. I figured out what was going on, and it's fixed, and it's now working very well, as you can tell from my little test audio there. And so yeah, this was a bit more of a pain than I thought it was going to be, but I'm happy with it. It works. Everything else works except the ABC, and maybe with a new tube in there, that would work too, because, like I said, this one is shorted, and this one, well, it's questionable. The tube tester, the better tube tester, which hopefully if it's working right, tells me this tube is junk. So, and when I discovered that article that said, well, you know, if the ABC isn't working or you don't want it, you can just pull the tube and pull that capacitor and you're done. So that's what I've done. So this is going to work just fine without that tube and without that headache. And I'm going to wrap it up here. If you've watched it this far, thank you. And hopefully we'll see you on the next video. My goal is to put out a video on my Zenith radio, which is a precursor to the transoceanic. But it's either a precursor or it's a lower cost radio that was released just before or just about the same time as the transoceanic. Depends on who you talk to, I think. But anyway, so hopefully I'll see you again soon, and we'll go through something else. Thanks for watching.